Hello everyone. This is a very short session on the remaining problems of discrete probability distribution. Okay, so State Board textbook exercise 8.1. Exercise 8.1. Uh, we'll go to question number uh, page number 141, question number 5. Page number 141, question number 5. Okay, so exercise 8.1, page 141, question 5. Right. So here they are asking find the probability distribution of number of successes in two tosses of a die if success is defined as getting a number greater than 4. Okay. So now see, try and understand one thing over here. There are two tosses of a coin. There are two tosses of a die, sorry, not a coin. So n is equal to two trials. We are conducting two trials or two experiments. Two times we are throwing the dice. Okay. Let P be success. Okay. So now see, try and understand PB success for one trial in one throw. Don't consider two throws, but then consider only one throw. Okay. So P is basically the success. So if we are throwing a dice once, if we are throwing a dice once, so numbers which are greater than 4 are 5 and 6 upon all the numbers 1, 2, 3, 4, 5, 6. So this is equal to 2 upon 6, which is equal to 1 upon 3. I hope everybody is understanding. We are throwing the dice twice, but then probability of success is only for one throw that I have considered. So when I'm throwing a die once, so the number greater than 4 are only 5 and 6 out of 6 different numbers. So these are two events out of a total of 6 events. So 2 upon 6 is equal to 1 upon 3. And let Q be failure. Let Q be failure, which is equal to, you know, remaining numbers. So 4 out of 6. Which four remaining numbers can you think of it? Okay, so the four numbers are 1, 2, 3, 4, because this 1, 2, 3, 4, these four numbers are not greater than 4. They are lesser than or equal to 4. So this is equal to 2 by 3. So we got the probability of success, we got the probability of failure in one throw. Now likewise, there are two throws. We are not throwing once, but then now we are throwing twice. Okay, and what is X? If you read the problem, X is the number of successes. X is the number of successes in two throws, right? So X can be out of two throws we'll get zero number of successes, one success or two successes, right? So further what I will do is I'll calculate the probability distribution because that is what we are supposed to do. So zero number of successes. So both the times we'll get a failure. In the first throw we'll get a failure, in the second throw we'll get a failure. So this will be 2 by 3 into 2 by 3, which is equal to 4 by 9. Okay. Now second case is one success. So in the first throw we might get a success, which is P, and in the second throw we might get a failure, or in the first throw we'll get a failure and in the second throw we'll get a success. So failure or success, so which is equal to 1 by 3 into 2 by 3, or is plus in probability, just remember or is plus. Okay, 2 by 3 into 1 by 3, right? So if you calculate this will be 4 by 9, right? And the last one, two successes. So it will be success into success. The first throw will give you a success, the second throw will give you a success. So that is equal to 1 by 3 into 1 by 3, which is 1 by 9. So this is what is asked. This can be a 3-mark question, right? Now let us go to the next problem. I hope everybody has understood this problem. Question number 6 from page number 141. A sample of 4 bulbs is drawn at random. So n is equal to 4. We are drawing 4 bulbs at random with a replacement. With replacement means we are drawing one bulb, okay? Then we'll replace in the total lot. The total lot is of 30 bulbs. So the total lot is of 30 bulbs, okay, out of which 6 are defective. So defective and non-defective, right? So let P be probability of getting a defective bulb or defective bulb. So 6 are defective, so 6 upon 30. So probability of getting a defective bulb is 1 by 5. And Q is equal to see, non-defective bulbs will be 30 minus 6, which is equal to 24, right? So 24 upon 30, right? Just a second. Which is equal to 4 by 5. 6 fours and 6 five. So we have calculated the probabilities of getting a defective bulb and the non-defective bulb. Okay. Now we are taking 4 bulbs at random. Okay. So for in try and understand, when we are taking the first bulb, okay, we'll replace the first bulb back into the entire lot. Okay. See, let me just reframe this for you all. There are 30 bulbs, right? 30 bulbs hai apne paas. So first bulb is taken out. We are testing for defective and non-defective bulbs. We are calculating the probability. Then we are putting it back into the entire lot with replacement. The meaning is that we are putting the first bulb back into the lot. Then we'll pull out the second bulb. Again, we'll put the second bulb back into the lot after noting down the probability. Okay. Likewise, we'll do for all the 4 bulbs. Okay. So what is X? We have to define X. X is the probability distribution of number of defective bulbs. Number of defective bulbs. Okay. So if X is the number of defective bulbs out of 4, so we can get we can get 0 defective bulbs. We can get 1 defective bulb. We can get 2 defective bulbs. We can get 3 defective bulbs. We can get 4 defective bulbs. Okay. But then we cannot get 5 defective bulbs because we are only pulling out 4 bulbs. So out of 4, there cannot be 5 defective bulbs. We are taking 4 bulbs at random, and X is the number of defective bulbs. So case 1, X will be 0 defective bulbs, 1 defective bulb, 2 defective bulbs, okay, 3 and 4 defective bulbs, and their respective probabilities we are supposed to calculate. Now I'll show you the calculation on separately on different pages, right? So case 1, when X is equal to 0. Okay, so when X is equal to 0, there are 4 bulbs, right, which are drawn back to back with replacement. So the first bulb will be, defective, non-defective, sorry, because there are 0 defective bulbs. So the first bulb will be non-defective. So it will be Q, probability of a non-defective bulb. Second bulb, again non-defective because we don't require defective bulb. Third bulb, non-defective. Fourth bulb, non-defective. So this is Q raised to 4. And what is Q? Q we have already calculated. Q is 4 upon 5. Okay. 4 upon 5 raised to 4. Fine. So we can write down the answer as 4 upon 5 raised to 4. Right? Try and understand. I'll help you understand this case once again. When we are taking out four bulbs back to back, not even once we should get a defective bulb. So first bulb will be non-defective, second bulb will be non-defective, third non-defective, fourth non-defective, right? And it's with replacement. Now when X is equal to 1, we are supposed to get 1 defective bulb. So first time we might get a defective bulb, second time non-defective, 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 or we'll get first time a non-defective bulb, then a defective bulb, then non-defective, non-defective. defective is P, non-defective is Q, or we'll get the defective bulb at the third time. So first two will be non-defective and the last one will be non-defective, right? Or while pulling out the bulb, the last one will be a defective bulb, but then first three will be non-defective. Okay, last one will be defective, but then first three will be non-defective. Now, how to calculate this? See, try and understand. Okay, so this part I'll just solve it up. P into Q cube plus, there is one P and three Qs, plus why I'm using plus, because of OR. Okay, one P and three Qs plus one P and three Qs. So this is equal to 4 into P into Q cube. So 4 into 1 by 3. P is 1 by 5, sorry. P is 1 by 5. And Q is 4 by 5. 4 by 5 the whole cube. Right? So this will be equal to, this 4 cube into 4 will be 4 raised to 4. And 5 cube into 5 will be 5 raised to 4. So this also will be 4 by 5 the whole cube. I hope you understood the entire solution for the one defective bulb. So 4 by 5 the whole raised to 4. Okay. When x is equal to 2, right? So we require two defective bulbs. So first two we might get defective bulbs. The last two will be non-defective. Or first and third will be defective. The last one, the second and fourth uh, draw, or when we are pulling for the second and fourth time, it will be non-defective. Or the first and last will be defective, but then middle two will be non-defective. Or second and third will be defective, first and last will be non-defective. Or second and last will be defective, first and third will be non-defective. Or, okay, so I think there is one more case left. Last two will be defective, and first and second will be non-defective. So see, everywhere you are having P square Q square. Okay, two P's and two Q's. Okay, everywhere P square Q square, P square Q square, P square Q square. So this will be 6 times P square into Q square. I'll explain this once again if anybody is confused. See, first time when we are taking a bulb, it will be defective. The second time will be defective, and there are two defective bulbs. The last two will be non-defective. Now, while taking out the bulb, the first and the third will be defective. Second and the fourth bulb drawn will be non-defective. Then first and the fourth will be defective. Middle two will be non-defective. Okay, and then the next case is, while taking out the bulb, the second and the third will be defective, but then first and the last will be non-defective. Then second and third will be defective, first and third will be non-defective, and the last two will be defective, first two will be non-defective. So we'll calculate this further. 6p is 1 by 5 the whole square, and this is 4 by 5 the whole square. I'm just putting the value of p and q over here, right? So this is equal to 6 into 1 by 5 square into 4 square by 5 square. Okay, so this is 16 6 are 96 upon 5 raised to 4, you can say. Okay, so 96 upon 5 raised to 4. Okay, by the way, you have to just expand this. Just expand this in your solutions. It's not a very huge number. Okay, yeah. So next one will be 3 defective bulbs. When x is equal to 3 defective bulbs, So first case will be first three defective, or first two and the last one will be defective, third one will be non-defective, or first and the last two will be defective, the second one will be non-defective, or the last three will be defective. Okay. Now in each of the following cases, P is appearing three times and Q is appearing once. Look at each and every case individually. So P cube 3, P cube 3 plus P cube 3, which is equal to 4 times P cube 3, right? So 4 into 1 by 5 the whole cube into 4 by 5. Okay, so this will be 4 into 1 by 5 cube into 4 by 5. So this is 16 upon 5 raised to 4. 16 upon 5 raised to 4. Now 5 raised to 4 is 625, that you all know. You have to calculate the final answer on your own. I'm just writing in terms of fraction and with indices. You expand this. Don't solve it in decimals. That's fine. And last one, all are non-defective. All are defective. Sorry. So all four are defective out of four bulbs. All four are defective. So this will be P P P P, which is equal to 1 by 5, which is equal to P raised to 4. So that is 1 by 5 raised to 4, which is, you can calculate 1 upon 625. So this is 1 by 5 raised to 4. Okay, so that is 1 upon 625. So this is the probability distribution, okay, of the number of bulbs, of the number of defective bulbs to be precise. Then one last problem that you should be very much aware of. Okay, so that is question number 8 from page number 141. Question number 7, sorry, question number 8 we have already done. So this is question number 7. A coin is biased so that the head is 3 times as likely to occur as tail. Okay, biased as in, it's not like head and tail. Head and tail probability is not 50-50%, it is something else, right? So that's a biased coin where the probability is not 50-50% of heads and tails. Okay, and they're asking, they're giving us, there are two tosses, and out of the two tosses they're asking the number of tails. So X is the number of tails. So X can take up what all values? 0 number of tails out of 2, 1 tail I might get, or 2 tails I might get. So this probability distribution they are asking, right? But then here it's not very simple because it's a biased coin, not an unbiased coin, right? So let P be probability of getting tails. A tail, sorry, not tails, but then a tail in one throw. Okay, so let this be P, probability of getting a tail, let it be P, right? Okay, then probability of getting a head, it is Q, but then they have given in the problem very clearly, the head is 3 times likely to occur as tail. So head is equal to 3P, 3 times of the tail. So Q is equal to 3P, right? Okay, now P plus Q is equal to 1. P plus Q is equal to 1 since it's a probability distribution, okay, for one throw. So P plus 3P is equal to 1. Therefore 4P is equal to 1. This gives me P is equal to 1 by 4. Okay, P is equal to 1 by 4. And if you put this over here, you'll get Q as 3 by 4. Okay, now many students might get confused why I have taken P plus Q is equal to 1. See, because it's a probability distribution of one throw of a coin. So we might get a head or we might get a tail. So probability of getting a head is P. Probability of getting a tail is P. Probability of getting head is Q. And summation of all probabilities is equal to 1. So P plus Q is equal to 1, right? And why I'm taking Q as 3P? Because heads will occur. Head will occur 3 times as that of tails. And this is also mentioned in the problem, right? So what I've done is Q is equal to 3P, that I'm putting it over here. Okay. I got the value of P, and that P I'm putting it over here. I got the value of Q. So in a nutshell, P is equal to 1 by 4 and Q is equal to 3 by 4. Now there are two tosses. So in the first toss, there are two tosses, right? So out of the two tosses, 0 times we'll get a tail. That probability we are supposed to calculate. So 0 times a tail. So it will be P into P, because P represents tail. Okay. So it will be 1 by 4 into 1 by 4. That is 1 by 16. Sorry, 0 number of times we should get a tail. So I did it wrong. Sorry. So 0 number of times we should get a tail indicates both the times we'll get heads. So that will be Q and Q, right? So excuse me for that. 0 number of times we are supposed to get tails. तो पहले भी tail नहीं आएगा. Second time also tail should not come. So first time non-tail is heads, so it's Q. Second time also it should be heads, so it is Q. So that is equal to 3 by 4 into 3 by 4, which is 9 by 16. We have calculated the values of P and Q. So this is 9 by 16. Now second time when X is equal to 1, that is one tail out of two tosses. So it will be tails and heads, or heads and tails. Heads and tails. So it will be 1 by 4 into 3 by 4 plus 3 by 4 into 1 by 4. So if you just check this, it will be 6 by 16. And both the times we are getting a tail. Both the times we are getting a tail. So that probability will be, both times tail. So it will be PP. I'll show it here itself. So 1 by 4 into 1 by 4. So the first time I'll get a tail, and the second time also I'll get a tail, and tail is represented using P. So P into P, that is equal to, you can show that calculation later. Okay, P into P, that is 1 by 4 into 1 by 4, which is 1 by 16. So this is what is asked. These were a few difficult problems from probability distribution of a discrete random variable. Thank you.